Welcome to Arrowhead Center for Theoretical Physics. This is another video on this lecture series based on quantum mechanics. So in the last lecture I have given introduction of Schrodinger equation and how wave function psi, which is the function of position and time, contains all information related to subatomic particles. So at time t, probability of finding a particle within the location x and x plus dx, this is x and this is dx, so x plus dx within this limit is the square of the probability amplitude. So this is the wave function psi xt. If we write the probability as dp, then we can say that dp is equal to psi xt dx. This is the probability of finding a particle, a subatomic particle within the limit dx. And you can see that this psi xt magnitude, square of the magnitude is not equal to psi xt square. Why? Because psi xt or wave function can be complex. It can be complex number. That's why there is a modulus, square of the modulus of psi xt. We have written square of the modulus of psi xt, and we can write this square as psi xt multiplied by its complex conjugate. So this is the square of the modulus of psi xt is wave function and its complex conjugate. So this is how it means. Now we can write Schrodinger equation as E in a three-dimensional form, IH to M Laplacian operator psi RT plus V RT psi RT. This Laplacian operator is equal to del 2 psi del x2 plus del 2 y2 plus z2. This is the three-dimensional form of Schrodinger wave equation. Now, if there is a three-dimensional space, then we can write dp equal to psi rt, its modulus, square of its modulus dx, dy and dz, or we can write dv. dv is the small volume. Within that small volume we can find a particle, or you can say that within the small volume there is a high probability that we will find the particle. Now Schrodinger equation has two important properties, that it is linear and homogeneous, and it is the first order differential equation with respect to time. You can see that it is the first order differential equation, first order differential equation with respect to time. So these are two important properties And as far as solution is concerned, suppose psi 1 and psi 1, psi 2, psi 3 are the solution of this wave equation, then Schrodinger wave equation, then we can also say that linear combination of this psi 1, psi 2, psi 2 can also be the solution of this equation. So according to the superposition principle, so this psi can also be a what you call solution of this equation. And also we can write psi rt or psi xt is equal to psi x and phi t. So we can separate psi rt into the two separate variables by the separation of variable, where psi x only depends on x and phi only depends on t. So this is the probability interpretation of wave function. And let us take one example related to this. So there is a particle, this is example, there is a particle trapped in a potential well where Vx is 0, where from 0 to a and infinity. So we have to show that psi xt equal to a sine kx and exponential iet divided by h. We have to show that this wave equation solve the Schrodinger equation. Also we have to prove that E is equal to h square k square divided by 2m. So how we can solve, how we can prove that this wave function can solve Schrodinger equation? So here Vx is 0, it means we can take V is equal to 0, or it will become I h del psi xt divided by del t is equal to minus h square by 2m del 2 psi xt by del x2. Now first of all we have to differentiate psi xt with respect to x. So when we differentiate psi xt, this is minus I exponential minus iet by h. So when we differentiate, first of all we have to differentiate with respect to t. First of all we have to find this t, psi del psi by del t, and we will get by differentiating this one with respect to t, we will get simply del psi by del t. We will get ih del psi by del t, we will get simply e psi. This is the value of left hand side. Now when we differentiate this function with respect to del psi by del x, and again with respect to with respect to x, it means we have to differentiate this psi with respect to x 2 times. So how much we will get? We will get h square divided by 2m k square psi. This is the value for right hand side. So these two value we will get, and when we equate this equation, we will get k square psi is equal to E psi. So how much we will get? E is equal to h square k square by 2m. This much. This is the value we want to calculate. So E is equal to h square k square by 2m. So this is the solution for the, so this wave function can solve the Schrodinger equation. So next video we will talk about how to solve this wave equation of Schrodinger.